Okay, today's lesson is going to be a little bit different. What we're doing is we're moving on to cones and pyramids. Now, cones and pyramids are really, they're actually related in a way to cylinders for cones and for prisms for pyramids, depending on the base of the pyramid. And you'll see why in a second. So we're going to do the lesson on mymaths today. And you'll see some cool facts, I think, about the link between cylinders and cones and prisms and pyramids. So firstly, a cone has the same volume as a fraction of the cylinder that surrounds it. So what fraction of the cylinder does the cone make up? What that means is the cone here that you see is a fraction of the cylinder that is around it. But what fraction is it? Well, it's a third. So if we squished that cone down, it would be a third of the volume of the cylinder. Okay, so you can just see that again. I'll go back, see if I can go back and show that again. So look here, and as we go, if we squished that cone down, it would be a third of the cylinder that surrounds it. Okay, and that's where its formula comes from. Now, what I would encourage you to do in this lesson is just kind of make notes in your book. The title can be Volume of Cones and Pyramids. I know the lesson says Volume of Cones and Spheres, but we've done spheres, haven't we? And this does actually cover pyramids as well. So that's what I would advise for you to do. Pause the video whenever you want to make notes. There's a lot of making notes I think you'll be doing on here. So here you can see the volume of a cylinder is given by V equals pi r squared multiplied by the height. Therefore, for any cone, the volume is a third of that formula. So a third pi r squared multiplied by the height. Okay, so that is something that I would, put in your bubble, put in your highlighted box. Okay, that's the volume for a cone. Okay, so this is a good example to copy down. You can call this example number 1. So find the volume of this cone. So it's got a diameter of the circle at the bottom of 6 centimetres, which means your radius would be 3 centimetres. And it's got a height of 8 centimetres. And I want you to imagine the cylinder that would surround it. And the cylinder would be 3 times the volume of whatever. Oh, it's a loud motorbike going by, sorry. And that cylinder would be 3 times the volume of this cone that it would encapsulate. So here's your formula. Your volume is a third pi r squared multiplied by the height. Your height is 8 and your radius is 3, just like I said before. So you substitute those values in and you get a third pi times 3 squared times by 8, which you get a third multiplied by 72 pi. And we know that multiplying by the third is the same as dividing by 3. And so you get 24 pi centimetres cubed, which if we pressed SD on our calculators would be 75.40 centimetres cubed to 2 decimal places. Or as it says here, you can leave the answer in terms of pi or as a decimal, whichever the question asks you to do. So let's have a go here. Find the volumes of the shapes, enter your answers as multiples of pi and as decimals to 2 decimal places. So let's do a few. I mean, we can probably do them quite quickly. So a third multiplied by pi multiplied by 4 squared multiplied by 12. Now, I've left my calculator somewhere, so bear with me. I'll be back in a second. Now, actually, if this was a non-calculator question, you could, of course, do that without a calculator. So let's do it without a calculator first of all. So volume equals a third times by pi times by 4 squared times by 12. So let's sort that out. Now I'm going to do a third multiplied by 12 because I can do that because remember multiplication you can do in whatever order you want. And you sort of end up then with a third times 12 gives you 4. So you end up with 4 pi times by 16. Which is 4 times 16, which is 64 pi. So 64 pi centimetres cubed. And then if we did that in our calculator, pressed SD, 201, oh no, wrong box, 201.06 to 2 decimal places. Let's try this one. Volume is 1/3 times by pi times by 6 squared multiplied by 5. Now I'm going to work out the 6 squared first of all, because I think I can then multiply that by 1/3. So I've got 1/3 times by pi times by 36 times by 5, and obviously 1/3 times 36 is going to be 12. So you get 12 times pi times by 5, which is 60 pi. So let's put 60 pi in there, and then press SD, 188.50 if we round to 2 decimal places. Then this one, interesting, 2 cones put back to back. Our radius here would be 1. Let's find, I wonder if there's a different way we can do this. Yeah, there is, because if you think about it, you would have 2 cylinders that would make up 1 cylinder here, and that would still be 1/3 of that volume. So you can still, I think, use the same thing. So your volume is 1/3 times by, what's your radius? Pi times by 1 squared, but then multiplied by the height, which is 6. Let's see if this works. If it doesn't, then we can just go back and times it by 2. So 1/3 times by 1 squared times by 6 would just give you 2 pi. Well, let's see if that works. And 6.28. Let's see if that works. Oh, it does. Perfect. Good. So you don't even need to think of those as 2 separate cones, because if you really think about it, this would be 1 cone here, and this would be 1 cone here of height 3 meters. So they would both have height 3 meters, but together that's just a cone of height 6 meters. And these would still be 1/3 of each of them, so it's still going to be 1/3 of the total thing itself. So that's a way you could think about that as well. Okay, now quickly for the pyramid, similar sort of thing. Now obviously for a cone, the surrounding shape that is around it is a cylinder, because they have a common face, don't they? They have that circle at the bottom, and the cylinder has the cross section. However, if we've got a pyramid here, the volume of a pyramid is 1/3 of the prism that surrounds it, and the prism that surrounds it is decided by the base of the pyramid. So as you can see here, we've got a square-based pyramid. Therefore, the prism that would surround it, depending on its height, would either be a cube or a cuboid. For this, I think it is given as a cube, that's fine, but that would depend on the height. So to find this volume of this pyramid, you would just have to find the volume of the cube and multiply it by 1/3. So let's have a look at these. Well, this here is a square-based pyramid, but its height is 3. No, it's a rectangular-based pyramid, sorry, because we've got 5 and 3 here. And then we've got a height of 3 as well. So that means this is a cuboid that is going to surround this. Now, to find the volume of the cuboid, you would do 5 times 3 and then multiply by the height. So your volume would be 1/3 times by 5 times by 3 times by the height, which is 3. So 1/3 times by 5 times by 3 times by 3. And so if we sort that out, I believe that gives us 15 centimetres cubed. And this one here, this is again a rectangular based pyramid. Don't worry that it looks a bit wonky, that's still fine. It's still going to be 1/3 of the cuboid that's going to encapsulate it. So you've got 4 here, 7 here, and imagine that the cuboid is around it, you would then multiply it by the 6. Because remember, for a cuboid, it's length times width times height. And that's basically what we're doing. Width times length times height, aren't we? Okay, and then so we would multiply that by 1/3. So volume is 1/3 times by 4 times by 7 times by 6, which is 56 meters cubed. Let's see if that's right. Lovely, good. So you have to look at the shape and decide what prism is going to surround it. Now, obviously, if it's a triangular-based pyramid, then it would be a triangular prism that would surround it, and you'd have to take that into account, because remember, you would have to do the area of the triangle, which would be half times base times height, and then multiply by the length of the pyramid. Now, we have done spheres, so that's all good. You could also be asked for this, a hemisphere and a cone, to find the volume of. That could be something that you were asked to do, but I'm not going to ask you to do that now. So I hope you made some notes here. What I'll do is I'll try and see if I can post a little example of the pyramids here for you to copy down, because there wasn't really an example that I could use to copy that down. So I'll do that as well. And then once you've done this, can you go on to the corresponding homework on mymaths and complete that for your lesson for today? Any questions, just let me know.